So eventually we're going to be solving by factoring, but we need to remember some stuff first before we get there. And so I want to talk about factoring just for a second. Going back to elementary school, you were asked, what are the factors of 9? What are the factors of 9? 3 times 3. Those are factors of 9. What else? 1 times 9. These are the things that multiply to give us the 9. So the factors turn out to be 1, 3, and 9. Those are the factors of 9, the numbers that multiply to give us a 9. All right. And we have factors of, say, 12. What are the factors of 12? 3 and 4. What else? 2 times 6 and 1 times 12. Whoops, there's 12. Okay. So we know what factors are, but now we want to apply that in an algebra setting. So we need to know how to take things apart. So when we factor, we break things apart into something times something. And that's factored form. Okay? And that's what we're going to be doing. That's our ultimate goal, except not with the plain old number. We're going to be doing it with algebra. Okay? So before we get there, today, our super easy job today is just to multiply. Today is a super easy day, which is very good. There's E. There's an E. A through E. I'm going to show you 2 ways to multiply. I'm going to give you 2 structures, really. The one you're all familiar with, the one you're probably less familiar with that I happen to love and adore. We're going to multiply using the distributive property. We have 4 times the quantity 3a plus 7. 4 times the quantity 3a plus 7. What do we need to do? Distribute the 4. What does distribute mean? What operation are we doing? Multiplying, yeah. That's all it is, okay? Multiplying. So what is 4 times 3a? 12a. What is 4 times 7? 28. And these 2 statements are equivalent, and we're done. Can I add the 12 and 28? No, they're not like terms. Don't do it. Okay, next, B. We have the quantity x minus 3 times the quantity x plus 5. These are called binomials. Write that down. This is a binomial times a binomial. I lovingly refer to them as bubbles. Do they look like bubbles to you? Do you see the bubble? Do you see the bubble? There's a bubble there. I lovingly call them bubbles. And when we get to factoring, we'll call it double bubble. All right. Okay, so here we need to multiply. Again, there's that little invisible multiplication symbol in between our bubbles. All right, and so we are going to do exactly what we did before. We have to distribute. We're going to take the x and distribute it to both terms in that second binomial. X times x is? X squared. Very good. Let's be clear, because I'm glad you said that. X plus x, 1x plus 1x is 2 x's, but x times x is x squared. Okay, be careful. X plus x is 2x, but x times x is x squared. X times positive 5 is positive 5x. You always make sure you have a sign. Now we're going to distribute negative 3 to the other side. And you'll notice my little rainbows I like to draw. Those are really important. Negative 3 times x is negative 3x. And negative 3 times positive 5 is negative 15. Raise your hand if you remember doing this. Yeah? Good. Okay. And what can we do as a final step here? Combine like terms. Very good. We have an x squared. What's 5x minus 3x? 2x's and a negative 15. Very good. And this is our final answer. We are done. Can we do any more combining? No, that's good. If this was a binomial, an x and a negative 3, what do you suppose this thing is called? Trinomial. Very good. Trinomial. So, tri as in 3, right? Okay. Nomial is Latin for name. So 3 names here, but really we interpret that as terms. So there's 3 terms. Binomial means 2 terms, an x and a negative 3. All right, letter C, we've got 2t minus 3 times 5t minus 7. What are we going to distribute first?
2t.
2t. 2t times 5t is 10. 10 what? T squared. 2 times 5 is 10. T times t is t squared. 2t times negative 7 is negative 14t. Then we're going to distribute what? We're going to distribute the negative 3. Always take the sign and include the sign to the left. So negative 3 gets distributed. Negative 3 times 5t is negative 15t. And negative 3 times negative 7. Positive 21. Again, use the entire number. Include the sign in front. Negative 3 times negative 7 is positive 21. And then what's our final step? Combine like terms there. So we have a 10t squared. What's a negative 14 and a negative 15t? Negative 29t's. Very good. And a plus 21 for our final answer. Fantastic. D is interesting. What do we do with this 2x minus 5 quantity squared? Plug it into your calculator. You wish. Nope, not going to work. What does a power mean? If you have 5 squared, what does it mean? What does it? 5 times 5. It means repeat what's below 2 times. We must do the same thing. We're going to repeat what's below 2 times. It means write it out 2 times, ladies and gentlemen. This is the number 2 biggest mistake in algebra ever. Okay? Now that we've written it out 2 times, repeat twice. All right? Now we can distribute just like we were doing before. 2x times 2x is almost 4x squared. Good. 2x times negative 5 is negative 10x. Then we're going to distribute the negative 5. Negative 5 times 2x. Another negative 10x. And negative 5 times negative 5 is positive 25. Last step. Combine like terms. So we have 4x squared. What's a negative 10x and a negative 10x? Negative 20x. And then the positive 25. We have one more to do, but before I move on, I want to think about something really fast. We ended up with a trinomial here, Is it always going to be a trinomial? No. Sometimes these middle terms actually cancel out. And so you'll end up with just 2 terms, and that's okay. All right. What I would like to know is, where did this 4x squared come from? How did we get it? 2x times 2x. Where did the positive 25 come from? Negative 5 times negative 5. So the first and the last term here come directly from these bubbles pretty easily. And we really want to hold on to that thought, okay? Same thing here. Where did the 10t squared come from? The first 2 numbers here, 2t and 5t, gives me 10t squared. Where did the 21 come from? The negative 3 and the negative 7, the last positions here. So the first term came from the first positions, and the last term came from the last positions. Okay? We really want to hold on to that. That's what we're going to do on Monday, going backwards. All right, last one. We have the quantity x plus 2 times the quantity 3x squared minus 4x plus 5. What would we call this first bubble? What's its proper name? Binomial. Very good. And what would this second bubble be called? Trinomial. Very good. It's important that we know the language. Binomial times a trinomial. Now, binomial times trinomial, we can do this the exact same way we have been, but it's not my favorite way. So I'm going to show you the box method, which is my favorite way. And what we're going to do is we're going to create a rectangle, because it turns out that, give yourself a nice big box, a nice big rectangle on your paper. It turns out that multiplying, all multiplying is figuring out area, okay, always. And so what we're going to do is we're going to fill in the area of this box. I'm going to write my trinomial along the length of my rectangle, 3x squared minus 4x plus 5 along the length of my rectangle. And I'm going to put my binomial along the width of my rectangle, my x and the positive 2. And what this does is just, I'm going to go ahead and divide up my box into little regions. And then we're going to multiply all the little parts and fill in the area. This is a nice little organizer. For something like this, the box method is very useful. Now our job is to multiply 3x squared times x. What is 3x squared times x? 3x cubed. X squared times x is 3x cubed. Here in this upper box, we're going to do negative 4x times x. What's that? Negative 4x squared. Very good. X times x is x squared. Good. Here we have 5 times x. 5x. Very good. In my bottom row here, we have 3x squared times 2. 6x squared. Then we have negative 4x times 2. Negative 8x. And then we have 5 times 2, just 10. So we have this lovely, beautiful area filled in, and all I need to do is combine like terms. Does 3x cubed have any friends? No, so it just comes straight down as 3x cubed. Then I have a negative 4x squared. Does it have a friend? Yeah, it does, a 6x squared right there. Nicely, they sort of line up on the diagonal. 6x squared minus 4x squared is positive 2x squared. What about the 5x? Does it have a friend? Yeah, the negative 8x. We're going to combine those. Negative 8x's and 5x's is negative 3x's. And then does the 10 have any friends? No, it's just a positive 10. And there is our lovely little product. Okay? Can you use the other way? Can you do the distribution method? Yeah, absolutely. You can distribute your x to 3 places, and you can distribute the positive 2 to 3 places. The problem with that is it goes on forever in a line. It gets a little bit messy, and sometimes you lose your place if you aren't as meticulous as I am about drawing rainbows all over the place. Okay? But you can do it. I much prefer the box method because it keeps things neat. Okay? Can this box be any size?
Yes.
Sure. If we had to multiply a trinomial times a trinomial, all I need to do is make my box a little taller. So I have a trinomial on top and a trinomial on the side. Okay? It also works with binomials too. Just a little small 4-square box. Okay? It's a very cool method, ladies and gentlemen. Do you have any questions for me? Wasn't that the greatest lesson? Nice way to end a Friday. You should have time today to not only finish today's lesson in Delta Math, but finish any other assignment. Maybe do the extra credit worksheet. Ladies and gentlemen, get started.